Hello, good morning. This is Aishwarya Nair from VIT University, Chennai. So here we are going to discuss about Fourier transform infrared spectroscopy or FTIR. So before we discuss about FTIR, we need to know more about what is infrared region. Infrared radiation or the region lies between the visible and the microwave portions of the electromagnetic spectrum. Infrared waves have wavelengths which are longer than visible and shorter than microwaves and have frequencies which are lower than visible and higher than microwaves. So they are divided into near, mid and far infrared. Near infrared refers to the part of the infrared spectrum which is close to the visible light, and far infrared refers to the part which is closer to the microwave radiation. Mid infrared is the region which is in between these two. The primary source of infrared radiation is thermal radiation. It is a radiation which is produced by the motion of atoms, molecules in an object. The higher the temperature, the more the atoms and molecules move and the more infrared radiation they produce. Any object radiates in infrared, even an ice cube emits infrared radiations. So according to the principle of infrared or according to the principle of IR, applied infrared frequency, if it is equal to the natural frequency of vibration, then there is an absorption of infrared radiation. Every bond or functional groups require different frequency for absorption. Hence, characteristic peaks is observed for every functional group or part of the molecule. So, FTIR spectra is basically used to identify the different functional groups that are present in a certain sample. For example, here in this spectra, we see isopropyl alcohol and the different functional groups which are associated with the isopropyl alcohol. So the FTIR spectra, you can see transmittance on the y-axis and wavelength can be seen on the x-axis. Y-axis can also have absorbance. So depending on that, you will get a spectra, and the various peaks will tell you at which all points the functional groups are present. For example, you can see OH stretch, carbon-hydrogen stretch can be seen. Carbon-carbon stretch can be seen, carbon-oxygen stretch can be seen. So a lot of bonds can be seen in a FTIR spectra. Now what is FTIR? FTIR stands for Fourier transform infrared spectroscopy, and the preferred method of infrared spectroscopy is that when an IR radiation is passed through a sample, some of the radiation is absorbed by the sample and some of it is passed through. So when you observe a FTIR spectroscopy, you can take it either on the basis of the transmitted energy or on the basis of the absorbed radiation. So the resulting spectrum represents the molecular absorption and transmission, creating a molecular fingerprint of the sample. So what all information can FTIR provide? So it can identify the unknown materials, what all materials your sample is composed of, and the quality, the consistency of the sample, the amount of components in a mixture, the different functional groups present in the sample, etc. Now the superiority of FTIR. When compared, you can compare FTIR with various other dispersive infrared spectrometers, but they suffer from several advantages, for example, in terms of sensitivity, speed and wavelength, accuracy, etc. So most of the light from the source does not in fact pass through the sample to the detector, but is lost in the narrowness of the focusing slits in certain other dispersive infrared spectrometers. And the spectrum also takes several minutes to record, unlike the FTIR spectra, which takes few seconds to record. So dispersive infrared spectrometers scan over the wavelength range and disperse the light by use of grating, and these spectrometers suffer from wavelength inaccuracies associated with the backlash in the mechanical movements. So it is preferred. Why Fourier transform infrared spectroscopy is preferred over other dispersive or filter methods of infrared spectral analysis? The main reason is that it is a non-destructive technique. For example, if you take XPAs and all, the sample will have undergo some sort of destruction when it undergoes this particular method or technique. But FTIR is a very non-destructive technique, and it provides precise measurement method which requires no external calibration, which means the measurement that you get is accurate. It can also increase the speed, sensitivity, greater optical through output. It is mechanically simple with only one moving part. So here you can see how the light source from the source through a slit, it reaches the sample and then it reaches the detector, and how it is detected. We can know the theory of FTIR then. The FTIR spectroscopy was developed in order to overcome the limitations which are encountered with dispersive instruments. So the main difficulty was the slow scanning process, a method for measuring all of the infrared frequencies simultaneously rather than individually was needed. Okay. So now what we have is the advantages of FTIR. FTIR has various advantages, out of which speed, sensitivity, mechanical simplicity and internal calibration method are the most important ones. For example, when we come to speed, because all of the frequencies are measured simultaneously, most measurements by FTIR are made in a matter of seconds rather than several minutes. Sensitivity is dramatically improved with FTIR for many reasons. The detectors employed are much more sensitive and the optical throughput is much higher, which results in much lower noise levels, and the fast scans enable the co-addition of several scans in order to reduce the random measurement noise to any desired level. Next is mechanical simplicity. The moving mirror in the interferometer is the only continuously moving part in the instrument. Thus, there is very little possibility of any mechanical breakdown or any other sort of wear and tear, etc. Internally calibrated. These instruments employ a helium-neon laser as an internal wavelength calibration standard, and these instruments are thus self-calibrating and never need to be calibrated by the users. So because of all these advantages, FTIR is one of the very useful mechanisms to characterize any sort of materials. Thank you.